Alrighty. So we've been building some stuff. There's lots of command line things happening. We want to actually make my grandmother able to use this. So let's do that. So just going back to the terminology that we used at the beginning, metamask is the main thing that's going to enable us to do that, and Web3 from a code perspective. Cool. So this is what we're going to build. This is our website. It has a heading, has the string from the smart contract, has a little thing there, and then you get a text input. I hope you like my placeholder. Does Sharky like my placeholder, or is he not even here to troll? Yeah? Is it control? What's the zoom? Command. Oh. Yeah. Cool. So this is what we're building. We got the string. Down here at the bottom, we've got the last price that was paid, and this is the actual smart contract that we're interacting with. So this is the same one that we kind of showed you earlier that we had already deployed. It's the same source code we've been working with all night. You get the idea. The current values in here are this last amount paid. This is the amount in way again, and then this is the string that's currently there. So I want to enable you guys to actually play with this right now. So if you want, you can take out your laptop and follow along, and then you'll be able to change the string live on this screen. This will be very exciting. So step one is you're going to want to install metamask. So if you actually just go to this URL here, the sidjs.koina.ge, it will yell at you and say, you need metamask in order to use this page. So then there'll be a link there for you to do that. So once you install metamask, it's going to just sit up here in the corner. So I've already got mine installed. I've agreed to the terms and conditions. I've already created a wallet, whatever. You'll also see I've cheekily loaded myself up with some ETH. So these are the different networks that you can set up on metamask. So normally you'd want to use the main network, but in this case, we're just doing this all with Rinkeby, so you guys can play along. So if you select Rinkeby, then it'll say account, and you'll get an address. You can actually copy that address to the clipboard. You're going to need that. You're going to come over here to Google+. It's kind of a weird way that they do it. The reason they're doing it this way is you don't want one person to amass so much test ether that they can start just spamming everybody on the network and being bad actors. So we have to identify ourselves to the place that's going to give us this free test ether. So the way we do that is by basically attaching our address to who we are. So you can do this on Twitter, you can do this on Google+. I find Google+ the most reliable, hilariously. So what you do is you paste your address in there, you make a public post, you get the actual URL to that post, you take that guy, you look for this thing called a Rinkeby authenticated faucet, you paste that in there, and you say, give me ether. They give you two choices. You can either have 3 ethers, and then be able to get more in 8 hours, so on. Go ahead and choose the 18.75 if you want the most to play with, but then it'll lock you off for the next 3 days, so you can't get more test ether.
And maybe zoom in a little bit so everyone can see that.
Maybe. Yeah, so this is just a website. It's faucet.rinkeby.io. You put in that post URL, and then you just say, I want some ether, and then you can say how much. Now, I've already done this, so when I try to do that again, it's going to go, you're probably a bot. And then when I do that, it's going to go, no, you've already gotten yours, go away. And you can tell I've already gotten mine because metamask up here is saying that I have 18.75 ETH sitting in my little test network here. So cool, so I've got my ETH, I'm ready to go. If you do this and you follow the steps, you'll actually get some test ether. At that point, you can come to this URL. You can type in a new message. So I just type in whatever I want. This is the amount that I'm going to pay in ETH to do that. It has to be more than the last one. So the last one was this amount. So I'm going to bump this up minimally so you guys can all play with it. I'm not going to outbid you all. And you click this update message button. It pops up and it goes, cool. And I'm not sure if I can really zoom in on this effectively. It goes, cool. I'm going to go ahead and send this much ETH from this account, which I typed in here. And I'm going to call that actual contract function. So I now say submit. There's my transaction. You can actually, if you click on it, it'll open up and it'll show you that, but I don't want to do that because I want you to be able to see it update. Whenever we mine a block, again, 386 in the corner. Hope my internet didn't drop out.
Everyone knows what a 386 is, right? I mean, that's Kevin showing his age. Yeah.
Let's just have a look at that actual transaction. So it's still pending. Nobody's mined it. It's been waiting 46 seconds. Yeah.
So who's actually mining and authenticating the transactions on, say, the Rinkeby network? Because there's nothing in it for them at that point, right? Is it against a stripped down version running simpler hashing algorithms, or is it?
That's the full thing. There we go. They're doing it to keep the ability to run test code. So basically, the Ethereum Foundation wants you to be able to test before you go live. There's nothing in it other than getting more test ether for all those test beers you're going to buy me at the end of the night. So not that exciting, but yeah, but it's just there as a public service. Infura, interestingly enough, you don't have to pay for, at least yet. That's also a public service. There's a lot of people just trying to get this space established and not really getting much for it. And then there are people earning gajillions doing ICOs. Cool, so we already got people updating it. So basically, if I refresh this page, you'll see people are paying more and more. So now that you've seen kind of what we're going to build, I'll go into the actual code, which is here. So I use Create React App, very simple setup. I use this thing called React. You might have heard of it. Very exciting. This is all normal stuff except this guy. So I'm going to zoom through the React stuff really quickly, assuming that we've all kind of seen that stuff. I did use set state, so sue me if that upsets you, I'm sorry. When the component mounts, we're going to update the string and the price. And then we're going to do this get suggested new price. That's just the default text in here, just so that it auto-populates with the thing, so people don't have to guess what that should be. Then every second, we're going to do that again. Now, if you remember back in the Solidity code, we actually had an event that people could listen to. That is true as long as you don't use Infura. So when you use Infura, they don't support WebSockets yet, which means that from Web3, we can't subscribe to events, which is why I'm polling. But you can, there's a way to say, whenever this event happens, just give me a call back. And if you were connected to a real Geth node, you'd be able to get that update. So that's what happens when it mounts. We're just going to get the data that we need. This is what it looks like to get that data. So I'm just getting those two values, very simple stuff. This is for our form, so we're just doing controlled components here. And when you submit, it just does a little bit of really dumb validation, and then it tries to update the thing. Then we render. This is about as exciting as it gets. If my contract manager throws an error, then we're going to go ahead and render this error that helps people get set up. If we're loading, we're going to render a loader. And otherwise, we're going to render that form, etc. This is all very standard stuff, and this was all just the content that you see on the web page. This is nothing blockchain-y, this is just a render. So that's the React stuff, that's it. So if we go into the contract manager, this is where we start using our Web3 stuff. So we're going to pull in our ABI from our ABI file. I've already gone ahead and formatted it with Prettier for you, so you can see what that looks like. It's really quite simple. It's just saying there's a function. It has an input called incoming message. That function is called update message. You know, it is a payable thing that you can send ether to. It's a function. There's also a last amount paid function. There's also a message function. And then there's this message updated event. That's it. That's the whole ABI for this. So we import that. We get our Web3. I'm going to pull some utility functions off the Web3 utils just so I don't have to type that over and over again. This is a singleton. The reason I went ahead and used a singleton is because we're only going to interact with one contract instance from this page, so why bother managing multiple instances? Just have it so every time you talk to it, it's the same thing. So I just put this function here so that basically it enforces that the contract is initialized, kind of like lazy loads that contract, and then I just put it on top of all the other function calls. So anytime you try to interact with a thing, it's just in the background going to go make sure it's already got its contract. To do that, it's checking for window.web3. hang on, where did window.web3 come from? That's a little weird. It came from MetaMask. So when you install MetaMask, window.web3 is now publicly visible on every web page you go to. For this reason, they recommend you disable it when you're not using it, because people can tell you have it, they can tell what your address is, and they can tell how much you've got in there just because it's running. So that's kind of an exploit by design, but there it is. So that's, as soon as you've got MetaMask running on the page, window.web3 is there. It is a Web3 instance, but it's also a really old version of Web3, and it can change because whenever MetaMask decides to update, it changes. So this is why we're packaging our own version of Web3 as well, because we don't want to just randomly have that API change as users start changing their version of MetaMask. So what we do is we check that MetaMask is here. And then once it is, we just say, I want a Web3 instance, and go ahead and use that MetaMask provider. I'm going to go ahead and call this get network type. That just returns a string that says what type of network we're on. It's actually technically a guess of what type of network we're on. It's good enough. So if we're not on Rinkeby, I go ahead and just yell at you to say get on Rinkeby, because this only works on Rinkeby. This is our contract, so it needs the ABI and it needs the address. That's it. We just say, I want a contract I can interact with. Then if we want to be able to get that message from that contract, we just make sure we run that code above, make sure we have a contract. And then we say this.contract.methods.message.call. A lot of dots. The reason they have this format is, first off, that's just my instance of the contract. .methods holds all the methods on the contract. They don't pollute the actual naming of their own API with those, because then you could have clashes and that would get really nasty. So they just put them all in a thing called methods. .message is the actual call of the method. You can put parameters here, whatever you need to put. But the reason that they have you actually do the .call is, as you'll see below, there's a difference between reading and mutating the blockchain. So this is just a read, so therefore we call .call. It's .send the other way. So if we want to update the message, we need to make sure we have a contract. We get the value of our price. So our price is specified to us as in an Ether amount, so we need to put that into way. So we go to way, and then this get accounts has to come from MetaMask. MetaMask has an old version of Web3. The new version of Web3 does promises. The old version only does callbacks. So I'm async awaiting everything, so that's annoying. I'll wrap it in a promise. So all we're trying to do here is get the first account out of MetaMask. So we do that. Then we say, I'm going to update the message with this new message. And I'm going to do a .send. .send means go ahead and mutate the state on the blockchain. To do that, I have to specify the address I'm going to send it from, and I have to specify the value that I'm going to send. For most smart contract interactions, that's actually 0, because you're just calling a function. You don't want to send money, but in our case, we want to send money because we're doing that whole bidding. You have to pay more than the last person. Get last amount paid is exactly like get that message. All it is saying call the last amount paid method. And then, of course, we get that back in way. If you guys are following along, so we have to convert that from way to Ether, which is what this is. This is the get suggested new price. We get the last amount. We add 0.0001 Ether. This is the actual add, because again, we're using a big number library to do that math. And then we return the result. It's just JavaScript. This is the thing, I went ahead and wrote it just so you could see what it would look like. If we wanted to subscribe to that event and it worked on the node we were talking to, this is what it would look like. So you say, I want to get the current block, because I'm only caring about blocks that happen after I've gotten my initial values. So the current block is the actual block number in the blockchain that is the current one right now. And then it's going to say, I want to subscribe to the message updated event from now moving forward, and call my callback when it changes, when that fires. That's it. That is the whole contract manager class. So from that, we get, just looking through here, literally everything else is just pure, pure create React app, and we've added Web3. That's it. Yeah.
The API.js file, that would have been generated from the bytecode or handwritten?
It's generated from the compiler, but for most smart contracts, you can actually come in here. So this is that contract that we deployed. You'll actually, if we refresh this, you'll see some new transactions of people. Oh, somebody's got a pending one from 5 minutes ago. So when you come into Etherscan and you upload your contract source, you paste it in here, you say what actual compiler you used, which it says up here, and then it compiles it and it will actually give you the ABI. So most contracts that you want to interact with will have gone through this process where they uploaded their source code. It's kind of a industry standard, as it were, that you verify the contract, that you prove that the source code you think that they've said that is the smart contract is the smart contract, and then you can just take this and go copy, and that's it. And then you've got that ABI file. And it's just JSON that is just saying how to talk to the thing. If I go...
So basically that means that it's a really collaborative kind of environment. Once someone puts their smart contract out there, publishes the ABI, it's kind of like an invitation for anyone to come and write dApps for it, you know. And so Kevin's done a reasonable job with this one, but look, someone who's like a UI wizard with React might come along and say, "I could do a lot better job." Come along and make, you know, animations and flash and things like that. So you get that kind of nice collaboration, you know, happening there because of, you know, because they publish the source code and generate the API that way.
Yeah. And it's all public. So like I wrote this dApp, somebody else could write another dApp that interacts with the same contract. Like I'm not controlling access to it in any way. It's all distributed. That's why we call it a dApp instead of just an app. But I still find that a little bit annoying because as you can see, there's like, what, 40 lines of JavaScript in there and I used a library. Cool. Call it something else, I guess, just to confuse everybody. So just a website. So do we all feel like we can build stuff with Solidity and Web3 and all the things? At least know enough to Google? Cool.
I know I can't afford that price.
Well, let's see what that price is. Oh, the price is low. Come on, guys. We can do better than this. So I'm going to outbid everybody for a bit here. So if you're on the main net, 5 ETH is about $6,000, just to be clear. Yeah.
Sorry, it used to be $6,000.
Yeah, I mean, it's probably $20 now, somewhere between $20 and $6,000. Yeah, that's how crypto works. One day you're crying, the next day you're cheering.
It's about 500 now, I think.
Cool. Somebody can beat my 5 now. Also, interesting to watch if you don't want to watch the dApp is just to actually watch the transactions come in. So like when we launch these things for real and there's thousands of people hitting them and sending money, it's actually quite fun to just watch 20 transactions, 20 transactions, 20 transactions, just see what everybody's doing. And you can come into every single one of these, see what Azros was interacting with it, see what they actually sent. You can see that they're talking to the contract, they're calling this particular function, they pass in an incoming message. This is the binary encoded version of those parameters, but if you click convert to ASCII, you'll see that was that one. So for all time now, these messages that we're putting in here are preserved in the blockchain.
So hypothetically, we could look at those addresses, cross-reference on social media.
You got an instruction. So you can cross-reference the addresses, yeah.
Yeah, on social media and sort of figure out where all those have all come from now.
Sure can. Also interesting, like if I wanted to run a business that accepted Ether as payment, when I give that address to people and say, hey, pay me in Ether, you could, as a customer, dig into that address and see how much money I've got and like look through all the other customers that have interacted with me and how much they've paid me for things. And that's one of the things that is kind of counter to how we think currencies work in the world we're used to, because we're used to it all being closed and private. There are blockchains that are more private and more closed, The main one would be Monero to look into, that is oriented in that way. But yeah, right now it's all just public info. So if you want to go in and see the Mt. Gox hack from way back when on Bitcoin, you can actually trace where all those Bitcoins have gone since and who has them and where they went and all the things. Yeah. Is the ATO looking? Yes, but the question is, how does the ATO, without checking this video, how do they know that this is my address? Because the only time you're actually putting the address on social media is to get this test ETH. And that's not my real address, that's a test address. So basically, those are all kind of obfuscated, I would say. I wouldn't say anonymous, I would just say they're there, you don't know who they are until somebody pops up and says, hey, this is me and this is my address. But if you want to receive payment, then you've done that. So you when you receive that payment, are immediately saying. So a lot of people will create a brand new address for every transaction, but then still, like, so you get the Ether and a brand new address, what are you going to do with it? You probably have to send it somewhere like into your big stash, so then the customer can just look and go, oh, well, you took it and then you put it in here and oh, you have X dollars.
Yeah, so ultimately you can follow the flow of Ether from one address to the other, to the next address to the other. Where the trail stops though is when it hits like the exchange, and it gets like, you know, it goes to the big pool and then you don't know when it's going to come out. So that's useful.
Or if you do this. Let's see if this hits up the Atlassian filters. No? Let's let this load. So this is a crypto to crypto exchange. So you say, I have 1 ETH and I wish to change it for Monero. And then you go exchange. And so they'll see ETH go into Changelly, and then it went somewhere.
For anybody dabbling in crypto, every time you change from one cryptocurrency
Yeah.
to another, that is that's an event that the ATO considers
Taxable, yeah.
And so if there's any change in value between the two things, you have to declare that, and that's every single transaction.
And that's capital gains tax. And
so that's a CGT point.
Yeah.
Exactly as if you were buying, I don't know, BAT shares and then you swap them for Barclays shares.
Unless you live in Singapore for 12 months, then you don't pay capital gains tax.
a lot of blockchain companies are now based out of the Cayman Islands. I'm not sure why. I'm totally sure why.
I want to sell something for $100, and that's worth an amount of ETHs.
Mm-hmm.
Does anyone ever do a transaction that says that's too many ETHs for what you're about to receive? Everyone just says, oh, hey, I got $110, something I was going to sell for $100 because the value of ETH went up.
Yeah, so like if you, the amount of, they kind of condescendingly refer to it as fiat. They just say fiat in short for like all of the US dollars, Australian dollars, all the fiat currencies from governments. The value of an ether is not pegged to any specific amount of fiat. And this is where it starts getting really interesting with regulation, because the Australian regulation says if you accept money from someone that's over 10,000 Australian dollars, then you have to comply with anti-money laundering legislation and know your customer. That you have to do that or you go to jail. So then the question is, well, if I receive 9 ETH, is that Australian dollars? Is that how much Australian dollars? There's actually like 30 different exchanges I can give that to and get Australian dollars back, and they all say different amounts. So what we do is we very much want to comply with the legislation. So we basically underestimate. We go, if it's about 8,000 or higher, we're just going to start complying early because we want to make sure that everything is absolutely above the board. And in that case, we have to verify your identity and all these things before we can actually hand over the currency. So all of that process is actually built into the smart contract as well. So most of what makes smart contracts complex these days is actually the regulation, not the technology. But I really believe in the regulation because I don't want to enable horrible things to happen with the things I build. So that's why we're actively working with ASIC and the other regulators to make sure that the things we're doing are above board. So with most projects, you have kind of design and dev working together. In this case, you have design, dev, the business goals of whoever the client is, plus a lawyer, plus possibly a regulator, and that's kind of your team that has to figure out how to do the thing. So.
So do you have like who are even the experts in this right now? Because it's such a new field.
I argue that anybody that says they're an expert in this, unless their name is Vitalik or somebody like that, they're probably not an expert. And what I find quite often is people will be like, yeah, I totally understand this space. And they'll ask him a somewhat in-depth question and they'll be like, I have no idea. So it's really hard. Ironically, we've built this trustless, decentralized system and now nobody knows who to trust. It's kind of where we're at.
Yeah, because we understand the technology is one thing, but understanding the law is like there is no right answer there because we don't know yet, right?
There is a right answer.
You could answer right now, right?
There is an answer as of today. So if you receive Ether, it's a barter transaction as far as the ATO is concerned. So it's like having received sheep for a tractor. And that's how you declare it on your taxes. So you have to declare the Australian value on the day you received it. Interestingly, though, the day, well, it can vary like $400 of value in one day. So what is the day? But, we take a value from the day and we declare that. And then when you sell it, there's capital gains on the difference. There is a whole bunch of regulation that applies today. We're constantly going, okay, what else is coming? How else can we get ahead of this? So the latest change to the legislation is coming in April, I believe. And we've already been working with it for the last 2 months. Like we're already working in that way because we just want to make sure that we're out ahead of everything and doing everything above board. But it's hard to keep up, not just with the technology. As you can see, like all the tools are changing all the time. There's like promises, callbacks, there's like new versions of the compiler, there's like Truffles packaging its own stuff. It's just wild, wild west at the moment. So the main thing is to just kind of, you got to really keep up with it if you want to keep up with it. But it's moving very quickly, and I'm really liking where we're heading. Yeah, so it's going to a good place, but a lot of movement.
How is it being adopted by like corporates? Is it being looked at from that point of view?
Yeah, I mean, I think what really caused everybody to take notice is Kodak said the word blockchain, and then all of a sudden their share price went up 30%. So when that happened, then all of a sudden a bunch of corporates were like, we need blockchain. And I'm like, why? And they're like, money. And I'm like, no, it's a 386. Don't use it like that. So there's a lot of people who are building applications right now that I would argue are better suited to a database, particularly if they're talking anything sidechain or private chain. A lot of that stuff doesn't need a blockchain to exist unless you're trying to like audit it and make it immutable, in which case, great, like that's a good technology to do it. But if it's a private chain and it's immutable, cool, but you can always just go back in history and then remine all the blocks on top. Like if it's a private chain, you control all the things. So you can 51% attack yourself and change all the history. So like, why are you using a blockchain then? And I think there will be a lot of use cases that pop out, but it's an interesting space. I think a lot of the corporates are just trying to figure out what it means for them. And the answer I would say is the biggest change in their minds is anybody anywhere around the world can interact with this smart contract that we just put up. There are no country borders here. There is no Stripe integration. There is no needing to KYC in this particular case. That's why we deployed it specifically to the test network to make sure that we weren't falling afoul of any legislation. But it just kind of breaks down all of those barriers that have been there for decades. And so if you're trying to control your money flow by geographical boundaries, this is going to mess you up. It's going to mess you up hard.
Sure.
No, just wait. It's fine. We got time.
So we talked about the just word mentioned legislation and
Yeah.
kind of how Ethereum and those sorts of assets get regulated at the moment. When we talk about the blockchain and we deploy a smart contract to the blockchain, that's there, right?
Yep.
Like even if the government said you have to take that contract down, there's no way you could. Right?
Correct. Well, you can kill contracts, but the fact that it existed and all the things that happened in it are still there forever. So if we built this particular contract, I can't kill because I didn't build the ability to kill it. But there is, one of the ways you could do it is you could just have a Boolean inside your contract that says, am I dead? Starts off with false, and then only the contract owner can set that to true. And before all your functions, you check if that's true, reject the transaction. So you can build them so that they can be killed. You can also build them so that they can be killed and point to a new one, so they're updatable. I'm going to use air quotes around that. So if you've engineered it from the beginning so that you can kill it, you can. But then you get a question from the whole community, which is, how is this decentralized? If you can kill it at any point, how do I know that that exists forever? And the answer is you don't. So there's going to be a lot of gray areas in the legislation here. And what we're doing is just making sure we're complying with everything as it goes. But yeah, you're absolutely right. Once you put data up here, it's up here. People can't change it. It's decentralized. There's no one to complain to. There's no one to take it down. There was actually a hard fork in Ethereum because there was basically a smart contract that was exploited and millions of dollars went away. And they split as a community over whether it was okay to go back and edit that smart contract or not to undo that event. So there's definitely, it's a hot topic. Some of the new platforms, for example, EOS will allow you to edit smart contracts, but then I start questioning, like, cool, it's great to be able to hot patch things, but have we committed to anything now? Now we can just go in and edit things. So basically, it's a very different headspace where you're effectively designing an entire economy from the beginning rather than just thinking about an app. So every little action you take can have dramatic consequences on the other side. If I have an if check, one if statement can mean the whole ability for that thing to be exploited or not. So it's a lot of thought that goes into those unit tests. That's part of the reason we covered it tonight, because like people are like, do you have to unit test? You could just build and deploy. It's like, no, you need to know how to do that, or you're not doing Solidity development, period, as far as I'm concerned. So, cool. Any other questions? Awesome. Thanks, guys.